Okay, guys, welcome to Math. I can see that it's Friday afternoon and it's a sunny day, and surprisingly I'm on my own, but I know that we haven't had a math video for about 10 days now. And we're going to start talking about reflection. So we worked an awful lot today on translations, and that is just simply sliding an image from one place on a graph paper to the other place on a graph paper. So now we're going to learn a little bit about reflection. So I want you to make sure you have your Cornell notes and a pencil because I'm going to expect you to take some notes here. All right, so the first thing that we're going to be looking at is what is a reflection. So a reflection is just what it sounds like. When you look in a mirror and you see a reflection, you are seeing the exact opposite of what is being reflected. So when I look in the mirror, the left side of my face should be looking at me from the other side of the mirror. So you look directly onto the thing, it's coming back at you. In that, the reflection is exactly the same. It's the same image that is flipped over. And you need to flip the image over a line. All right, so Stephen's just joined me. Lucky Stephen, he's the only guy on here. How you doing, Stephen? You didn't miss anything. I was just turned to this page. So we're going to give Stephen a second to catch up. He's going to write down, and I expect all of you to do this, write down what a reflection is. It's the same image that is flipped over. So in your Cornell notes, you should have some sort of mention of that. Because in the test for this unit, you're going to have to do two different things. You're going to have to do what we did today, which is called a translation, where you just slide something. And then we're going to do a reflection, which is when you flip something over. And the next one after this one is a rotation, which we need to use a protractor for. So each and every one of you needs to have a protractor when you come into class the next day. And a protractor is the little circle thing with the angles on it that's from your math set. So you need to have one of those available for class. So I'm going to move on to the next page. Let's talk about vocabulary. So the original shape in a transformation is called the pre-image, and that should go in your notes. So a pre-image is the very first thing that you do. So you all made one today when you worked with your partner on doing a translation. So you made a Cartesian coordinate, and then you drew an image into the Cartesian coordinate. That's actually the pre-image when we're doing these kinds of things, which are different kinds of what they call a transformation. So when you transform something, you change it from one thing into another. So when you're doing a transformation in geometry, it just means you're moving the shape so it's not in the same spot. Okay? The shape that you move, if the original shape is called the pre-image, then the shape that you move is called the image. And when you are using marking the vertices, you use the same letter but with a 1 to indicate it's a new image. So I'm going to show you that. I'm just going to put up a so I'm going to show you if I was doing an original, if I was doing my original point and it was M, and say M was 2, 1. Then I move my shape, and now I've got M, but it's in the new place. What I'm going to do is call that M prime, M1. So the one that's next to it is not a full one, it's a little one. Just to show on there that M prime is, say, we've moved the whole shape and now it's, say, 0, 3. I don't know. So I don't know how we would move it to do that. Those are just, I pulled those out of my head. Okay, so when you mark it at the original image, and some of you today had really simple images and some of you had more complicated images, but most of you didn't do that section when you did your graphing. All right. Now, one thing when you do a reflection is you have to say how you reflected your figure. So for example, you can say that you reflected a figure over the x-axis, or maybe over the y-axis, or maybe over x equals 1. Those are different examples of things you could use. Now when you put up this, you can see that I was working on a piece of graph paper in the background, and that's because we're going to actually do some work on this, and I want to use the page that I had. So here I have, let's reflect across the y-axis. So where is the y-axis? I'm going to use my pointer. And Stephen, you can use yours too if you want to. I'm not sure that I gave you that. So where do you think the y-axis is? That's right. Stephen and I both pointed at it. So the y-axis is there. So when we say that we're going to reflect this over the y-axis, that means that we're going to take this point here, and we're going to use that as a point for the reflection. So what we're going to see is a mirror image of what we did. Now up here, I've drawn, I'm not going to fill it in because you know I'm terrible at writing, but you can do that. So I'm going to put x and y here, and then we're going to call each point a point. So this one is going to be, this point right here is going to be A. So I guess I'll have to write that on. So that's going to be A. Now, if I'm going to reflect this over the y-axis, where do you think A prime is going to be? The place where we have the top corner. So this one is at, let's think, -2, and then we're going to go up 1, 2, 3, 4, 5, 6, 7. So the first one is at -2, 7, and that's A. So when we're looking at A prime, it's going to be exactly, because we're reflecting across the x-axis, or the y-axis, it's going to be on this side, and it's going to start right there. Now I just made a big mess there. I'm going to clear that off. And I'm going to get my, so I'm going to start right there. Now, how many I go across? Well, let's count. 1, 2, 3. So I started the second, and I'm going to go across 3. 1, 2, 3. Now, this is A prime. Do you want to move your pointer there, Steve? Stephen, can you take yours off pointer? And then, if that was A, and this is B, I'm going to just go back to using the pencil. That's a little bit easier. Thank you. This is B here. Then this is B prime. I'm going to mark that with a 1. All right. So we've done our top line. Now, is this line going to be the straight line or the crooked line? What do you think? How you erase, Stephen, is with the very top thing. You go up there and you click on it, and then you select the object, and then you can erase. Okay, so this is going to be our straight line here, because it's going to be a reflection, so it's a mirror image. So I'm going to take my line here, and I'm going to draw it here, and I'm going to come down. Now this one's an easier one to do because you can see it right there. So let's stop and look at what we've got here. All right. So we've got the same reflection coming across the top. How am I going to deal with this other thing? What am I going to do here? Any thoughts on that? So this line here is, I got to point to it, sorry, I always think you can see what I'm doing. This line here is exactly 6 boxes long. So I'm going to draw that line on the opposite side exactly 6 boxes long. So here I go. I think that's 6, 1, 2, 3, 4, 5, 6, 6. I swear this thing makes me cross-eyed sometimes. There we go. So the last thing I have to do then, and of course I didn't get this right in the corner there, I was terrible, is to join them up. So now we see we have the exact same shape reflected across the y-axis. So all I did was flip it over. Basically that's what I did. So now what we're going to do is we're going to figure out, okay, we've done that reflection. If these are the original points, A, B, C, and D, we see that A was -2, 7. What was A prime? What was A prime? Stephen, can you figure that out? It's 2, 7. Excellent job, Stephen. So it's 2, 7. So then B, what was B, the original pre-image? B was, and let's count over, 1, 2, 3, 4, 5, 6, 5, sorry. So it was -5, and then we're going to go up, 1, 2, 3, 5, 6, 7. So it's -5, 7. Now, what do you suppose B prime is going to be? You can probably figure that out without doing the counting. if A was negative 2, 7, and A prime was 2, 7, and B is negative 5, 7, then B prime is going to be 5, 7. Excellent, Stephen. So they should be opposites. So we're going to remember that we're writing this as B prime. All right? So let's check C out first. So it's 1, 2, 3, 4, 5, 6, 7, 8. So it's negative 8, 2. So what do you think C prime is going to be, Stephen? He already got it in before I even got it written down. That's right. It's going to be 8, 2. And we're going to call that C prime, and Stephen's going to write it on with his pencil. So write on where you think C prime is, Stephen. And while Stephen's doing that, I'm going to figure out my coordinates for D. Oh, he did it. C prime. Don't forget to put the little 1. Excellent. So now we're going to look at D. Now D in the original pre-image was 1, 2, negative 2, 2. So what is our image going to be for D prime? What is it going to be? Let's bring my line down a little bit farther. And Stephen says it's 2, 2. So if you check on the graph, you'll see that that's right. So that's basically how to do a reflection. You have to be careful. Oops, I got to write with a pencil instead of a line. Okay. You have to be careful when you do it that you reflect across a line. All right. So we could do another one. I'm just going to delete that. I'm going to clear this page off. Ta-da! I'm learning all sorts of new things with Blackboard these days. I remember this from the old days a while back, and I thought, oh my goodness, I've done so much work with graphing, and I forgot that they had an actual graph page. So I'm going to make a skinny triangle. All right. Now, if I don't quite make the corners, you guys know that I'm working hard to try and make the corners. It's hard to see. All right. So there's our Cartesian coordinates. And I didn't number them because it really is hard for me to write with this pen. It's just not something I've gotten good at. So we're going to write down X and Y, but we're going to count all of our points. Okay. So this is our pre-image, and we're just going to have A, B, and C. All right? Now, we are going to flip our image this time over the x-axis. All right? So our image is going to end up starting on this side of the x-axis. So if this is B, then what is the point that I've just written here? What is the point? Oh, Stephen asked if he can reflect it. And absolutely, Stephen, you can. So Stephen's going to work on that a little bit. Stephen, you can draw the lines. Can you see which one is the line tool? Yes, you can, apparently. Okay, now you have to be careful to try and make your lines match. So that one should only go as far as there. Okay. So Stephen's going to try reflecting, and we're going to be really encouraging to him to see. I'm going to take off my marks. Okay. So that's the first thing that he reflected, was the bottom line. Now what are you going to reflect? Oh, he's ahead of me. So he's counted his number of spaces. So if I look at this, I can see that from A to B is 1, 2, 3, 4, 5, 6. And I can see that Stephen drew 1, 2, 3, 4, 5, 6. And so far he's perfect. So there he is with his reflection. So now we're going to write onto the graph. If this is B prime, then what Stephen's going to do is he's going to label the rest of his graph with the other coordinates. Okay. C prime and A prime. And if we hadn't run out of time, which we're rapidly doing, then Stephen would be at this point able to do all his X and Y coordinates. Okay, excellent job, Stephen. Give yourself a pat on the back. I'm going to take you to the homework page. Here's the homework page. Stephen, if you want to write this down. Plot these points on a Cartesian coordinate system and join them to make a quadrilateral, and then reflect the quadrilateral across the x-axis. So it sounds like a lot, but it's really not. You're just drawing one thing and you're reflecting it. So if you can't remember how to reflect, you're going to go back and re-listen to this video. So Stephen, as soon as you've got your homework done, then you can go, but thank you very much. So the points are 2, 5, 7, 5, 3, 2, and 8, 2.